So here is another nice trigonometric problem where we are given a triangle and some values in tan, and we have to find the relation between the sides of a triangle. So let's try to solve this problem. So first look at the information that we are given. So first thing is the value of tan a by 2, which is 5 upon 6. Then the next is tan b by 2, which is 20 by 37, and the last value is tan c by 2, which is 2 by 5. So first thing is that I'm going to take the reciprocal of each term. So what we can say that cot of a by 2 is equal to 6 by 5. Similarly, cot of b by 2 is 37 by 20, and cot of c by 2 is 5 by 2. And if you observe the values 6 by 5, 37 by 20, and 5 by 2, then you can see that they are in AP. So let's check my claim. We have to just equate its denominators. We can simply, for the first term, we can simply multiply it by 4. So in numerator we'll get 24 by 20, and then this is our 37 by 20, and our next term we have to multiply by 10, so we'll obtain 50 by 20. And it's very clear to see that there is a difference of 13 in between the consecutive terms. So we can simply say that this is our AP. So now what we can say that since we know that cot a by 2, cot b by 2, and cot c by 2 are in AP, so we can simply say that twice of cot b by 2 is equal to cot a by 2 plus cot c by 2. And now I'm going to use the formula that we know for any triangle. So this is our formula in term of a tan, so we can transform it in term of cot, of course. And so let's start transforming it. So first is tan a by 2, which is equal to square root of s minus b multiplied by s minus c upon s into s minus a. Similarly, we have two more formulas in term of b and c, which is tan of b by 2 is square root of s minus a multiplied by s minus c upon s into s minus b. And similarly, for c by 2, we can say that square root of s minus a multiplied by s minus b divided by s into s minus c. So we can transform this tangent in term of cotangent by just taking the reciprocal of both sides. So let's do that. So we can say that cot of a by 2 is equal to square root of s into s minus a upon s minus b multiplied by s minus c. And similarly, we can say that cot b by 2 is equal to square root of s multiplied by s minus b upon s minus c multiplied by s minus a. So here we obtain the all values in term of cot, and we can simply put the value in the equation, which is twice of cot b by 2 is equal to cot a by 2 plus cot of c by 2. So we can simply put the values in this expression, and we'll obtain that in the right hand side twice of square root of s multiplied by s minus b upon s minus a multiplied by s minus c. Similarly, inside the square root we'll get that s multiplied by s minus a divided by s minus b multiplied by s minus c, and further s multiplied by s minus c upon s minus a s minus b. For solving this further, we have to multiply this expression by square root of s minus a s minus b and s minus c. And here I multiplied by the quantity both side, and here we can see some nice cancellations, like here s minus a from s minus a and s minus c, and we'll obtain that twice of s multiplied by s minus b whole square. And similarly, in the right hand side there is also some nice cancellations that we can perform, and we'll obtain the s multiplied by s minus a whole square plus, here we can cancel s minus a and s minus c, and we'll get the square root of s multiplied by s minus b whole square. Here we can simplify further, and we can say that twice of s minus b is equal to s minus a plus s minus c. Oops. This must be c there. And here we can multiply this 2 inside the bracket, and we can say that twice of s minus twice of b is equal to, here we can add these two terms and we'll get twice of s minus a minus c, and after cancelling this term we can say that twice of b is equal to a plus c. So we obtain this result, and if we go back to our options, then we can simply say that the first option is our correct. Twice of b is equal to a plus c.